Hello guys, welcome back to the channel. In previous lecture series, we have seen one of the very important module of engineering mathematics, that is Laplace transform. Now onwards, we will see another important module of your engineering mathematics, that is inverse Laplace transform. So it is the inverse of the Laplace transform, that's why it is called as inverse Laplace transform. In the chapter Laplace transform, we have seen Laplace transform of any function of t is equal to phi of s, means the conversion of t function into s function is called as Laplace transform. So therefore, inverse Laplace of phi of s is called as f of t. So Laplace of f of t is called as phi of s, and inverse Laplace transform of phi of s is called as f of t. Means the conversion of s function into t function is called as inverse Laplace transform. Now we will see the list of various formulas of inverse Laplace transform, and we will see some numericals. So we have seen the list of various formulas of Laplace transform in the previous lecture series, that is Laplace transform of 1 is equal to 1 upon s, Laplace transform of e raised to minus or plus at is equal to 1 upon s plus or minus a, etc. So inverse Laplace is nothing but the inverse of this Laplace transform. For example, if Laplace transform of 1 is equal to 1 upon s, then Laplace inverse or inverse Laplace of 1 upon s is 1. So like that, we have the list of various inverse Laplace transform of the various functions. Now let us see one example to get you an idea about how to apply these formulas. So we have first example, we have to find inverse Laplace transform of 1 minus root s upon s square the whole square. So first of all, let us use the formula of a minus b the whole square to solve the numerator. So a square minus 2ab, which is 2a into b plus b square. So root s into root s upon s square, and square of that will become s raised to 4. Now we will split the numerator. So 1 upon s raised to 4 minus 2 upon root s upon s raised to 4 plus s upon s raised to 4. Now we will write 1 upon s raised to 4 as it is. 2 also we will write as it is. We have root s in the numerator. Root s is nothing but s raised to half. If it comes in the denominator, it will become s raised to minus half. But in the denominator we have s raised to 4. And from this we will get s raised to minus half plus 4. We will get minus 1 1 1 plus 4 2 8. So 7 by 2. So we will write 2 upon s raised to 7 by 2, and we have s, it will come in the denominator, it will become s raised to minus 1. So s raised to 4 into s raised to minus 1 will become s raised to 3, that is s cube. Now we will use this list and we will find out the inverse Laplace transform of the given functions. See the list. Here we have 1 upon s raised to 4. So if you see this third and fourth formula, it is applicable for these functions. So see this 1 upon s raised to n and 1 upon s raised to n. But for the integer, for an integer, formula number 4 is applicable. Okay. So it will become t raised to n minus 1. Here n is 4. So it will become t raised to 4 minus 1, that is 3, upon n minus 1 factorial. That is 4 minus 1, 3 factorial. Now here 2 is constant. I will write as it is. Now here also the formula number 3 is applicable, that is 1 upon s raised to n. So it will become t raised to n minus 1. Here n is 7 by 2. It will become t raised to 7 by 2 minus 1 will be 5 by 2 upon gamma n. So gamma n is 7 by 2. Now here also 1 upon s raised to 3, formula number 4 is applicable. It will become t raised to n minus 1, that is t raised to 3 minus 1 is 2, upon n minus 1 factorial, that is 3 minus 1 is 2 factorial. This is your final answer. So that's how we will apply. So that's how we will use this list and we will find out inverse Laplace transform of any function of s. Now we will see an important property of inverse Laplace transform, that is shifting theorem. So you know that inverse Laplace transform of phi of s is equal to f of t. Suppose they ask you to find out inverse Laplace transform of phi of s plus or minus b. Okay. So we have the direct formula of shifting theorem, that is inverse Laplace transform of phi of s plus or minus b is equal to e raised to, if here it is plus it will become minus, if it is minus it will become plus, bt into Laplace inverse or inverse Laplace of phi of s. Now we will see an example to get you an idea about how to apply this formula of shifting theorem. Suppose if they ask you to find out inverse Laplace transform of 1 upon s plus 5 the whole square. So you can see that here we have the formula of 1 upon s raised to n. Here with this s we have an extra part, that is plus 5. We have the formula for 1 upon s square, but here the plus 5 is an extra part. So this plus 5 is nothing but the plus b in this formula. So here b is equal to plus 5. So let's apply the first shifting theorem. So we will get e raised to, so as I said, if here it is plus it will become minus. So plus 5 will become e raised to minus b, that is 5. So 5t. Now what will be the remaining part? So if you neglect this plus b, that is plus 5, you will get 1 upon s square. So 1 upon s square is nothing but your phi of s. 1 upon s square. Now we will write this e raised to phi t as it is. Now we have the formula for 1 upon s square, that is 1 upon s raised to n. Here this 2 is an integer, so this formula is applicable. So we will get t raised to n minus 1. So t raised to 2 minus 1, that is 1 upon n minus 1 factorial. So 2 minus 1, 1 factorial is 1. Okay, so this is your final answer. So that's how we will apply the shifting theorem to solve the inverse Laplace transform of type phi of s plus or minus b. Now let us see another example. So the given numerical is, you have to find inverse Laplace transform of s minus phi upon s minus phi the whole square plus 4 square. So first of all, you have to see the list of the formulas and you have to see which formula is similar to this example. So see, here with this s we have the extra part minus 5, here also minus 5. So as I said, the b here is minus 5. So now neglect this minus pi. What is the remaining part? S upon s square plus 4 square. So if you see this formula, it is Laplace transform of s upon s square plus a square. It is similar to this example. So now let us apply the shifting theorem. Here it will become e raised to, if it is minus, it will become plus. So minus phi, here we will write phi t plus phi t into, so as I said, except this minus phi, what is the remaining part? That is s upon s square plus 4 square. So this is nothing but your phi of s. Now let's apply this formula. Here it is s upon s square plus 4 square. So here a is 4. So now according to the formula, we will write cos a t, that is cos 4 t is your final answer. So this is the shifting theorem, and we have seen some examples to get you an idea about how to apply the shifting theorem. Now we will continue our chapter, that is inverse Laplace transform, in the next video. Thank you very much for watching.